just press record. Okay. And then I'm just mostly going to screen share. And I think the way, let me see who's here, because I don't know how technical to skew this. So it seems like probably everyone here knows JavaScript, which is good, because I was actually even planning to talk to non-technical people. But if I can assume that everyone knows JavaScript, then I can I can skip some stuff. Okay, so let's see, does it look good here? Okay, I can just use my own site, right? All right, so the context of this thing is that on the developer experience team, we've been working on a VS Code extension, and it was more or less decided that it was not tenable otherwise unless we use TypeScript. And Sarah Jasner actually asked for a TypeScript lunch and learn, and it's not something that we use in Netlify, but it is a trend in the developer community. So I figured, why not? I'll do the lunch and learn. Unfortunately, she then couldn't make it today. So this will be a recording partially for her and whoever else cannot attend today. Yeah, so this is more or less an intro for people who've just never used it before. You don't have to know, you don't have to use it even after this. This is just more like, why are people keen on this? What is it about? And some basic facts that you should at least know when talking with people who use TypeScript. Someone's not muted. Okay. I'm just going to keep going, but whoever that is with the noise, you might want to turn that back. So the basic TypeScript branding is that TypeScript is JavaScript that scales. And you can see their site at TypeScriptLang.org. And the way they put it, I always was originally put off by the way they branded themselves, like as a type superset of JavaScript. That's always seemed like a little bit like a superiority complex type of thing. And I was never a fan of that, but it's technically true, and it's all about set theory. Like the goal is not always 100% the case, but the goal is that valid JavaScript is also valid TypeScript, and then there's extra stuff on top of TypeScript, on top of JavaScript, that makes TypeScript unique. And I'll go into a little bit about that as well. The things they focus on, I kind of put it in 3 C's. Constraints, like adding type constraints onto your code. One way I'll demonstrate that right now. I got this Zoom thing that's interfering with my clicking. One way I'll explain that right now is here. So so I can say let ABC equals to hello, and I can try to assign number to that ABC, and it'll give me an error. This is perfectly valid JavaScript. Under this scenario, TypeScript will give you an error because they want to put constraints on what you can assign to which. So having a string and trying to assign a number to a string is not valid over here. I said something in the chat. I recommend moving the Zoom menu box elsewhere on your screen. I have it at the bottom. Jessica, I thought you couldn't see it.
Oh, we can't, but you said it was in your way. So I was just going to say, like, if it's in your way, you can move it. But it sounds like you moved it already. So, yeah. Or maybe you didn't. But
I moved it.
It can be moved.
Yeah. So anyway, so that's the rough like introduction. Let me zoom out a little bit and just talk about like the overall setup of what we're going to do today. So we have basic questions. We have motivations. I have a little talk about like the WAT, the famous JavaScript video about how bad JavaScript is. We'll talk about the attributes of the type system, what the design goals are. And this is really intended for people who already know some type systems and just want a basic reference of what the comparable attributes are. We'll talk a little bit about tooling, about criticisms, migrating. We'll have a little call to action and some resources. I even included resources for non-technical people, people who don't like types, people who think tests are good enough. There's a lot of, this is a very deep topic that I spend a lot of time on. So yeah, we're not necessarily going to cover everything, but I just figured it's important to give you the basic structure of what we're going to cover today. So it adds constraints. They ship a compiler, so they're very tooling focused. And for them, a compiler is not just a black box in one end, out the other. They expose APIs in the middle, so you can plug into them. So they really regard themselves more of a language service. And that's why VS Code and other IDEs also support TypeScript really well, as well as community. Like they have people on staff whose only job is community and dealing and fostering the community. And that's a big part of why they won out over Flow, which is the competitor type system in JavaScript. It might seem from a lot of the material out there that it's for front-end technologies, but it's equally applicable for Node. I've seen some concurrent TypeScript and service worker stuff that has no bearing on where it executes. It's literally everywhere JavaScript runs, TypeScript also runs. So when did TypeScript start? 2011, 2012-ish, released in 2012. And the context is important. They didn't work on this just because they missed types. They really, this was more or less like the start of the standardization of ES6, HTML5, and people writing ambitious web apps, and trying to make it scale, trying to make code bases that cohere across large teams. And that's why the branding is that it's about JavaScript that scales. It started life as Script Sharp, and this goes into a little bit of the history of the creator of TypeScript, Anders. Anders has 35 years of programming language creation experience. So he created Turbo Pascal, Delphi. Most people ignore J++, but then also C Sharp. He's still currently the chief architect of, and also TypeScript. So C Sharp was the project that he was on, and they tried to compile it to JavaScript to get it to work on the browser. And eventually they were just like, what if we just did a ground up redesign and just added, and just instead of focusing on C Sharp, just focus on JavaScript idioms and just try to type that. A big part of the adoption was in Angular when they jumped to Angular 2. They fully adopted TypeScript, and now a lot of the other players in the ecosystem are also involved. The TypeScript team is entirely funded by Microsoft. It's about 30 people. There's some in New York, and I hang out with them pretty often in the regular TypeScript meetups. In particular, one of the key people to know is the program manager, Dan Rosenwasser. So he's the guy in charge of community. If you have any issues, he's pretty responsive on Twitter, and he manages the roadmap of like what the feature is, what the feature development is. All right, so onto the TypeScript value system. So they put this above code, right? Like this is so much of a lot of the language design is also about what the promises are to its community. And so for them, it's open source and open development. So the entire code is on GitHub, and the release schedule is also on GitHub. You can see what they're working on and what they plan to work on month by month. And each of these things link to individual PRs. So extremely open. And they dog food everything as well. The goal is to closely track ECMAScript for features. So most of the, I think like 5 people on the team are also on the TC39 committee that decides on JavaScript features. And the goal is to not, they used to go ahead of JavaScript, and that no longer is a goal. So they implemented things like decorators and classes way ahead of their time. And that used to be a selling point, but now no longer is. So now their goal is to just have parity with JavaScript on that, and you only innovate in the type system, and so that's the extra stuff that's going to be stripped away at build time. Another goal is tooling support. They work very closely with the VS Code team, but then also on the compiler as a service. They're very keen on education, so they just hired Orda from Artsy. Orda is a very big contributor in the React Native space and one of the best technical writers in JavaScript land, I know. And he's going to work on the documentation, and I think that's very helpful as well. Community focus, I already mentioned about. So who's using it? Big companies. So these are individual links to their stories of Airbnb, Lyft, Google, Slack. I meant to put Uber here, but I forgot Uber. Anyway, so open source, Vue's moving to TypeScript, Jest, Yarn. Yarn actually is a Facebook technology, and that caused a little bit of controversy because they weren't supporting their own type system, and they just, they're using Microsoft's type system. Oak Cliff, I only put Oak Cliff here. Oak Cliff's not that big of a project, but it's the one that we use for our CLI, as well as Salesforce and Heroku and Stripe, and like it's more or less the emerging CLI framework that is not that's more full featured than Commander.js, which is the big one, as well as VS Code, which is a huge open source project. Surveys, number 10 language on Stack Overflow, number 3 most loved. I like to see the charts because like it doesn't look real until you just look around and like you look at like where it is in context with everything else, and it does seem like it's a pretty big deal. I also compiled the results from the State of JavaScript survey, and the numbers of people using it went from 21% 2 years ago to 47%. Interestingly enough, actually, it's not the people who are learning, like people, the percentage of people who want to learn it kind of stays constant, and it's the people who change their minds and the people who go from not interested to interested. So I kind of concluded that if you're not interested now, you may not stay that way. But the basic fact is that roundabout, as far as we can tell, between 50 and 60% of JavaScript users now use TypeScript. So they are now the majority, as far as we can tell, right? Obviously, there are a lot of people who just don't respond to surveys. But from every incident and every big opportunity that we've seen, it is the majority way to write TypeScript, including, and this is not a cop-out option. For example, one of the people I met at TinyMCE, they evaluated like even more strict forms of languages like Reason, ML, and Elm, and concluded on TypeScript because of the interoperability. So the story of incremental migration from JavaScript to TypeScript and not having to rewrite everything all at once is a very, very key part of the adoption so far. Okay, so primary motivations. I tend to put this up front, which is moving runtime errors to compile time errors. We really want, yeah, I mean, obviously runtime exceptions are bad, but then also it just increases the cycle of feedback. Runtime errors can take the form of production runtime errors or just in development. And even in development, there's a lot of velocity that's lost, developer velocity that's lost by defensive programming and local dev manual testing. And if there's any way we can automate that with our tools, it's worth exploring. Airbnb actually keeps very, I don't know how you call it, very, very detailed postmortems of production bugs. And they went back and studied all of them. And according to their talks, 38% of them were preventable with TypeScript. So the point is to catch them earlier, catch them faster, and enable tooling to do more with the same number of people. I think some of the hidden costs are a bit hard. So like there's increased benefits, but then there's also like we also need to lower the cost of doing existing things. I think we would all do a lot more refactoring and have less technical debt if it were easier. If we had tooling to help us, to tell us when our refactoring is off or buggy. So it would think with a better tooling and with a faster feedback cycle, we'd actually refactor more, and our code would be a lot cleaner to read. So that's the idea. Obviously, it's very hard to prove, and you can have individual cases that go either way. The other thing I also am very keen on is that you benefit from types that are not written by you. So I find that a lot of people who are against TypeScript or who don't think they need TypeScript, they have a very not invented here syndrome. which is that they prefer things that they write themselves. And so like that's perfectly fine because you have full control of that. But sometimes you can benefit from things that are written for you by the community. You can't copy and paste tests from other people, but you can copy and paste types from other people. And that's what the TypeScript community really does help you as well. Auto generation of types is also a thing, especially from the back end to the front end. So for example, if you're doing Open API or GraphQL or Swagger backends, all of these have types. You can flow them down to the front end and pick out things that are calls that you're making that are not legal, or if you're just not providing enough information, the type system can tell you instead of you running the code yourself. And the last bit is type inference. So these are all types that you do not write, but you benefit from anyway. And so these are all like under the general category of moving runtime errors to compile time. But I find that they're so nuanced that they deserve a broader discussion here. So it's a very famous talk. I don't have time to check if everyone has seen it, but I highly recommend it if you haven't seen it, the WAT talk. And basically talking about implicit conversions in JavaScript and why that's bad. Like the fact that you can produce runtime errors, and that's a design goal of JavaScript in the beginning, to be permissive, to be lazy in terms of how it evaluates and reports errors. So in TypeScript, we move the errors to something more eager. And the first three examples here are actually now errors in TypeScript, whereas it doesn't cover everything. So I actually like this example a lot because it basically tells you it catches some errors that you would have created in JavaScript, but it doesn't catch everything, and you still need tests for that. So types and tests do work very well together for certain things. Okay, so now on to attributes of the type system, and we'll do a little bit of maybe coding, maybe not. I don't know. But so the overall thrust that we're going for is that they're erasable, inferable, gradual, structural, generic, expressive, and OO and functional. This one's not that big of a deal. Like once you understand that TypeScript is entirely created to model JavaScript, and JavaScript is of course both OO and functional, then this is completely not a surprise. But I think that a lot of people have this impression of TypeScript as something that C# and Java developers like, and they see a lot of example code as OO, and so they conclude that it's not for them, and that's just plain not true. It's just not enough examples. So we do have to work in the docs. And I lifted this directly from Anders Hallsberg, Intro to JavaScript. And I was keeping in mind that these are words that are chosen extremely carefully, like to describe the differences in languages from the languages that the differences in type systems from the languages that he's worked on before, and why we've got to the point that we've got. So the first goal of TypeScript is that it's erasable, that it goes away when you run compile, right? So this is valid TypeScript. It's a person type with the first name and last name. We're assigning it to both the data type here. So the username is first name, last name. Then and we also have a function that accepts that data type here. So we use that type in both the input and the output. And then we call it, and this whole thing is type safe. And then once we run this through the compiler, it outputs to valid JavaScript, right? Which also does the exact same thing, but no longer has any notion of the types. It just has the first name and last name of that person. And so that means it's a very easy eject ecosystem, like eject workflow. Like the whole thing revolves around ejecting. So there are a lot of people who actually claim that you should not adopt TypeScript because someday there may be official versions of types. That doesn't ring very true to me because you can eject at any time. And also, this is by now and by far the most tried and tested type approach to JavaScript. So if this is ever adopted by the official ECMAScript standard, it'll probably look like this. Like even flow type doesn't look that different. So people have very bizarre objections to TypeScript. So in particular, I also like that they do not get sent to the browser as they compile away. A lot of proposals for additions of types add runtime weight that kind of you don't need. and when you actually run things. But it's still helpful, right? Okay, so that's the first property, that it's erasable. The second property is inferable. So inference means that we just infer the type of the variable based on what you've coded, and no other annotation anywhere else. And so here are two examples of where inference can happen. So here's it's the exact same example from above, but here I don't have any types. But here I can still infer the shape of the user object down in here just based on how I created it. There's no other way. It has to have a first name property. It has to have a last name property. But I do not infer on the function, even though within the function I still use the first name property and I still use the last name property. I don't infer from that. That's a conscious choice of TypeScript, and that's called non-local type inference. And we wanted to, and from what I can tell, TypeScript did not do that so that they can support JavaScript interoperation. But inference does mean that, for example, I'm gonna just copy and paste this code down here. Inference does mean that that it has the IDE, the type system, has validation and auto completion. I never specified any types down in here, but it's already inferred the type of this to be of an object with the first name key and a last name key. So now when I type this, it actually knows that, for example, this is a typo, right? And it gives me a proper error for this, and it tells me these things. This typos, I mean, it's pretty smart. It also understands string literals as well. So it also reads not just direct property access, but also indirect string literals, and that's useful in some cases. And it just keeps going. It's extremely deep for that. We'll talk a little bit more about how expressive it is. So gradual. So the other design goal, I think, is that it's super important is how it's a spectrum of strictness from very strict, check everything, error in everything, to allow everything, don't error in anything, but gives you some annoying warnings. And so there's a spectrum which you can have in any type which runs all JavaScript code, and on the other end is strict mode, which actually turns off a lot of implicit features. So for example, here I have it in strict mode. I'm going to turn it off. You can see I'm going to turn off all the flags. You can see that there's no errors right now because valid JavaScript is valid TypeScript. But now if I'm going to turn on no implicit any, that's going to start giving me an error on this guy, because it says this argument that's come into the function has been implicitly given in an any type. That used to be okay, but you said no implicit any in the flag, so of course I'm going to turn it off. So of course I'm going to error it now. And so the way to fix it, you can do multiple ways. Like, for example, actually specify that this will have a first. This is an object with a first name of string and a last name of string as well. Or you can use any number of type utilities that TypeScript provides to you. So, for example, if I've already have user defined here, I can just say type of user, and that resume share. Sorry, I clicked something and accidentally turned it off. And this provides the proper type of the user as well. So there are a lot of ways to gradually increase the sort of strictness of the types. And in fact, in the cheat sheet that I maintain, I actually have a migration guide somewhere with like levels. I didn't know what to call it. I was like, don't call this a step, because like you might have to do parallel things. I don't know. So like level 0 is don't use TypeScript, use JSDoc. I don't recommend that for most people because it's extra work for no benefit. And then there's ways to just opt in on a file by file basis to TypeScript checking. So just like the Netlify code base has Netlify front end has 50,000 lines of code. We can opt in individual files to see what the errors are, and use the TypeScript compiler to actually check our JS just for syntactical issues. The other one is a little bit more aggressive. Rename every single file to TypeScript from the beginning, and then gradually ratchet up the settings of the strictness, right? All of these, like turn all these off, and then just add them, and then just fix all of them all at once, and then add the next one and fix all the strictness issues all at once. So those are the strategies. It does take some skill to navigate them. I'm not going to pretend that it's easy, but it's there for you, and it's designed that people can do this with their code bases because it's meant to be gradual. It's not an all-for-one proposition. People will have this misperception as well. It's structural typing. So this is another property that people have like some issues with, but it's actually really cool. So most type systems are nominal, which means that, for example, here I've assigned a type of user ID, which is a string type. And here I've assigned a food ID, which is also a string type. I have here a function that returns user ID, which is a string. And I have here a variable, which is a food ID. So this should be an assignment error. Like it should be under a nominal type system. This would be a type error because I'm getting a user ID, which is user ID over here, and assigning it to a variable which expects a food ID. However, in TypeScript, this is not an error because we do structural typing. And what structural typing means is you only look at the shape of an object, the shape or how, I guess, I don't know. I don't like the word shape, but I don't have a better word for it. But it's called duck typing because if it looks like a duck, it quacks like a duck, it is a duck. And that's the way that it approaches typings. And that's actually, again, another choice for interoperability. So this is pretty handy in complex shapes as well. So for example, if in this function, thank you, Zoom. In this function, I expect an argument of person. Person is an object with a name property. So that accepts this object with no problems. But then I can also construct a person from a class with a nice constructor. And this class shape with a name property is also accepted by the exact same function because it's of the same shape. And so that's really good for interoperating complex data types, particularly like sometimes JSON files or whatever you're working with. You just don't have to manually like cast the type. In fact, there's no concept of casting in TypeScript. You can only assert a narrower type than you already had. And so if you're interested in that, we can talk about that. And from that basic building block, we can actually build up to nominal typing with a strategy called type branding. But also future, it will be first class with a new keyword that's in the works as well. So all the links are there. You should already have them. Generics. So generics are ways to make your types even more reusable. So everything here that we have so far, like you have to know the type up front. Like this thing is a string. This first name, last name is a string, a Boolean, a number, whatever, an object, whatever. What if you wanted to write a function that works on any type, right? Like all the types, you pass it in, and it's smart enough to know how to change what comes out. And so this is for example like a data structure that's a node that takes in whatever type, and it passes up and it has a parent of node, but it also has children of node. So it does recurse with the generic type as well. So so this is basically a type like function kind of. People actually can build a pretty complicated logic with this generic types. You can also use limitations and keywords. So for example, extends the limitation. So this function over here is an example of one of the more advanced generic types that you can get to. But just don't focus on that. Focus on this stuff. Like under regular JavaScript, you can totally see how I have an object here. I create a function, and I pass in a string that accesses that object, right? So it's literally let me just put it in here in the TypeScript docs. So in JavaScript land, it's literally you object access, right? You pass in an object, you pass in the key, and it accesses that object for you, and it returns that that value. But the point is, like, what if you wanted to be smart about the type? So over here, I have an object type with a type of with a property with a text property that's type of string, and a count property that's type of number. So what I want over here is that the object type, when I pass in an object type and I pass in text, it actually gets a string out, and that's kind of what it does over here with the string output value. But it's smart enough that when I pass in a count variable, it actually outputs a number over here as part of the function. And obviously, it raises an error when I pass in a key that doesn't exist. And so all of this is expressed by something like the type system. There's a particular grammar to it. It actually doesn't have that many rules, but it does look very alien to people when they start out. But that's the goal. The goal is to reflect the full dynamicness of JavaScript. It's so kind of like, I kind of blame, like, if TypeScript's type system is complex, it's JavaScript's fault. So there are all these patterns like object pattern, union types, which are very, very cool. Intersection types between different object types. Key of, you already saw lookup types. Lookup types were the ones with where I can look up the type of an individual property inside of an object. Map types, as well as conditional types. This is the most recent one and the most powerful in terms of the kind of type utilities it does enable. The type system is actually Turing complete. I don't know how you prove it, but here's the issue to follow up on if you actually want to check it out. But there's a lot of complex logic that we just don't have time to go over. But the whole point, again, is to reflect the full dynamicness of JavaScript. Okay, so, and then expressiveness. Yeah, so one of the things I do like about this is that we spend a lot of time in JavaScript land doing like maybe checks, like maybe this is undefined or it has a value in it, or, in something. So that's a very first class citizen in TypeScript. We call that control flow analysis together with union types. So this is a union of string and undefined. So this foo function gets an argument which is either a string or undefined, and TypeScript forces you to check before you access string. So for example, let me just do it over here. So if I don't do this check, right? So string is either this inferring correctly. I don't know what's going on over here. Hang on. I have a check strict options. Yeah, I think so. I'm not sure which option it is. Yeah, there we go. Okay, so if I try to do like to uppercase here, right, this will cause an error over here because the object is possibly undefined. We do this all the time in JavaScript to the point of introducing new operators to do falsy checks. But in order to force us to, so TypeScript will force us to check this by introducing a type check, so that we'll do, we'll check that something's undefined. I think we need to return a value over here. And so now we know this string operation to be valid because we've already ruled out the case of the argument being undefined at all. And so that's the rough idea. Imagine this for your Redux actions, your switch cases, your objects configuration checkings, all of these. Like, the only place that you defensively type is the one place where TypeScript tells you to do it, and everything else you don't have to defensively type it because you've constrained the surface area of where all of these missing null conditions are concerned. You constrained it to just right at the top where TypeScript tells you to do it. So that's control flow analysis, and that's pretty powerful. Here's an advanced example, which is called the discriminated union pattern. Again, the inference is such that in each individual location, even though this is a shape shape, I guess, argument here, inside of here, I can infer that the shape only has a property of radius, and because I've already switch cased it on circle, and inside of the switch case of square, I have a property of size, and that's defined by the type system over here. So it's very localized typing, and that's with the combination of union types as well as control flow analysis, that it just goes through and understands what it is. So if I did not return here, it would fall through as well, and it would have the requisite errors to warn you when you forget basic things like not returning and all that. So that's pretty helpful in just overall authoring. Okay, so I'm gonna pause here because I've gone on for about half an hour. Are there any questions that I can take from people? That's the overall. I'll just zoom up to the overall attributes that I've covered. Are there any questions that I can take? Just give it a few seconds in case anyone has questions. Okay, so yeah, I mean, it seems like Marcus already is day one here and already knows TypeScript. So if you already know TypeScript and I've omitted anything, please let me know as well, because this is the first time I'm doing a TypeScript intro. Nope. Okay.
Everything's fine. It's really good. You already like pointed out some features I didn't know yet, so it's good.
Cool. Yeah, thank you. And yeah, your voice is really welcome on the team as well. I also like, part of this is I've kind of invested in this quite a bit. I did a talk, one of my other talks. One of my other talks was a full book report on it was cultural learnings of programming for make benefit glorious users of TypeScript. And this is just more of a fun, like, here are some things that you don't know, which are more like edge casey stuff. This was actually at the TypeScript meetup. So I mean, this is a full language, right? It's as deep as you want to go into it as well. Okay, cool. I don't have that much, so I'm probably going to wrap up in maybe 10, 15 minutes, and then we can break early. Tooling, there's official tooling, obviously. I've heard TypeScript be discussed as a tooling-focused language. I don't see that reflected anywhere in the official docs, but I know that the core team actually do regard themselves as that's one of the core differentiators. And if you think about it, it's actually pretty cool how different languages have different focuses, and tooling is the main one. So the TypeScript compiler is not a black box. It operates as a language service, and therefore it plugs into everything everywhere. Their homage, like Dan Rosenwasser, the program manager, his tongue-in-cheek thing is that he wants types on every home and every desk, which is kind of the Microsoft slogan from Windows back in the day. And they've even done a lot of contributions outside of their own formal ecosystem. So they work with Babel to add TypeScript support. They work with Webpack they actually maintain the Webpack loader for TypeScript. All of these are not things they have to do at all. Like, they have a TypeScript compiler. You can use that, compile to JS, and then from JS, pass it through all the other Babel Webpack stuff that you want to do. But for them, integrating with all these things is something that they will spend employee time on. And so that's pretty cool. You've already seen the TypeScript playground. And so that's a way to, that's just a REPL to test things, but obviously there are many REPLs out there. As well as for Anders, his focus is very much on, the tooling focus is very much on the 250 millisecond response time. What he means by that is that when I type shape dot, it should take less than 250 milliseconds to give me all the options of circle, square, rectangle. And for a very, very large code base like the VS Code code base, he wants that to be true as well. So that's the goal. They don't always get there. There are some things in which TypeScript is justifiably slow, and they're working on it, and there are ways to mitigate it as well. So community tooling, I actually started this category and then I ran out of time. There is more community tools. The main thing to take note of is end-to-end typing. So a lot of people, if you're using like Airbnb's Thrift, GraphQL. So Airbnb does end-to-end typing. So their backend is in Rails and Thrift. I think they have a nice chart here. Whoa. Where is it? Here. Their backend is in Rails, passes through Thrift as a presentation layer. They have a GraphQL service. They generate the types to the client so that they have matching type usage over here. And that works extremely well for them. I think that's something that you have to have a lot of back-end and front-end collaboration on, because it does involve a lot of foreign work, especially for the back-end folks. But it's something that we can look into as well, because we use OpenAPI and Swagger. So I maintain the React TypeScript cheat sheet. It's de facto docs for the community, and I've done it for a couple years now, and it's just ways to get started. One of the things I'll highlight to people is the utility. So if you're actually keen on using TypeScript, one of the utilities I maintain here is also really cool. And these are all just things that a community has come up with to use TypeScript well. Yeah, these are all generic utilities that are pretty helpful. Okay. I also want to. I'm always a fan of truth in advertising, so I also want to cover criticisms of TypeScript. I don't necessarily agree with all of them. Reliance on build tools means you can't just write TypeScript in a script tag, and that's just like unfortunate but true. I also point out for us, Netlify, that reliance on build tools is actually a good thing. That's good for us. It increases build minutes, and we charge for that now. It's not ES standard. We already covered this. For some people are really funny. So Ryan Florence, the React router maintainer, tried out TypeScript, and then decided not to adopt it because it didn't offer enough type safety. So he just went with plain JavaScript anyway. So that logic is more like, as a maintainer, how much type safety do I want to advertise and offer, and how well do I think I can stand behind this? And if you can't stand behind it at all, maybe you don't want to use it at all. Obviously, that seems like a dubious decision, but that's entirely his prerogative. Some things are really hard to type. So higher order components involve a bunch of generics. And if you look at the Redux typing system, that's what the Redux maintainers are dealing with right now, trying to wrangle the dynamic aspects. Like, basically, if your behavior changes when you add an extra argument or change the type of an argument and just totally blows up, you not only have to account for the explosion in combinatorial value states that you can have, but also you have to reflect that in both your code and your type system, and reflect it all the way down, including your plugins and your middleware, and that's very, very noisy. So those are fair. So slow for large code bases. This is true, but also, again, like, note that it doesn't stop people like Atlassian and Slack and all those guys. Project references were released with TypeScript 3.0, and that actually speeds things up a lot. Some people criticize it for having a learning curve, which is gatekeeping to some people. Blah blah blah. There's other stuff as well. I also have a guide to migrate to TypeScript. I was planning to actually do some live coding on the Netlify code base. Unfortunately, it actually has full type in it, and then I was like trying to like, do I rip this out or do I not? And then I just like decided to abandon that procedure. But there are automated conversion tools for migrating the TypeScript, but obviously that doesn't get you. That only gets you so far, and then the rest is doing either the comprehensive switch and then you ratchet up the levels of strictness, or you do file by file and you can be as strict as you want. So that's the rough goal. And this is just some copy and paste things for converting the Netlify code base if we decide to do it. So call to action: copy and paste any JavaScript code into your TypeScript playground, and see what happens. See what it gives you. Play around with the options. Looks like my internet's not really resolving anything right now. And then I have resources here for TypeScript, like all sorts of TypeScript people, non-technical people who don't like types, people who think tests are good enough, so on and so forth. as well as courses and books that I recommend and will stand behind. Yeah, so that's the entire session. Thank you for joining me on this really random lunch and learn, and I'll stay for questions. But otherwise, have a nice day.
Thank you.
Ooh, I see emojis from people. Okay. Yeah, thanks. Thanks for joining.
I have a quick question regarding the migration doc that you have about migrating to TypeScript, the cheat sheet.
Yeah.
So I noticed you had different levels. So you had level 0, which is don't use TypeScript, use JavaScript docs. And then the last level of level 2 is strict TypeScript.
Yeah.
So does that correspond to how strict you want your TypeScript to be, or how in depth your TypeScript is?
Strictly percentage of code base that is TypeScript.
Okay. And I'm just curious, with regards to that, what is the trade-offs of I've seen teams use TypeScript as JSDoc. So because essentially TypeScript requires you to compile, it's at compile time, and JSDoc is just at runtime, because you're essentially if you have it within VS Code and JSDoc, you can kind of see the comments as you're coding. So it won't capture the errors, but I'm just curious what you see in terms of the trade-offs of using that versus migrating everything to .ts.
I see.
Yeah.
So it doesn't check internals of functions. So if you use JSDoc, which by the way, Webpack, all of Webpack is done like this, right? They try to have the best of both worlds with full JavaScript accessibility. Basically, the only place the types exist is in the comments, and then yeah, and so my issue with that is that it only checks at the boundaries, at the return values of the functions and when arguments are accepted. And it doesn't check anything inside, and your tooling doesn't benefit from that as well. So that's one thing. The other thing is that the importing story from ambient modules. So I use ambient modules a lot. Basically, ambient modules are what happens when you need to patch a type from someone. You're using a library that doesn't have TypeScript types, and you have to write your own. You write an ambient module and you patch it up. Or if a JavaScript library that has types recently changed their API, and the TypeScript hasn't updated alongside, then you have to patch it manually on your own. And again, you write an ambient module to patch it up. So JSDoc doesn't respect that. So I just don't use it.
So you can treat JSDoc TypeScript comments as TypeScript light, and then using TypeScript as intent, fully used. Yeah. Okay.
I think as well. So JSDoc is everything is fully explicit, and a big draw for me for TypeScript is inference, right? The types that I don't have to write. So for example, I often don't specify the return values of my React components, because it's of course inferred to be a React element. And in a JSDoc scenario, you just have to be explicit with everything. Yep. Cool. Well, thanks very much. And I'll record this and post it up. Okay, bye everyone.
Thank you.
Thank you.
Thank you.
Thanks.
How do I close this? Stop video, stop share.